Alright, so let's look at some applications or way we would apply this. Savings instruments in which earnings are continually reinvested, such as mutual funds and retirement accounts, use compound interest. The term compounding refers to the interest earned not only to the original value, but on the accumulated value of the account. The annual percentage rate, or APR, of account is also called the nominal rate. It is the yearly interest rate earned by an investment account. The term nominal is used when the compounding occurs a number of times other than once a year. In fact, when interest is compounded more than once a year, the effective interest rate ends up being greater than the nominal rate. This is a powerful tool for investing. We calculate the compound interest using the compound interest formula. This is all the same as before. Instead of P sub n, we just denote it as a function. So this is the amount over time. So this is the account value over t years is equal to P naught times 1 plus R divided by n, all to the nt power. So everything's the same, except we just call this something different. So this little chart here just shows if I invested $1,000 at 10% for 1 year, if the frequency of the compounding changes, so does the value. So if I just did an annual compounding, it would be $1,100. If I did it semi-annually, which is twice a year, it would be $1,102.50. If I did it quarterly, it would be $1,103.81. If I did it monthly, it's $1,104.71. And if I compounded it daily, it would be $1,105.16. So the more compounding periods, the better your investment, and conversely, the more compounding periods, if you're paying a loan, then how much extra you would have to pay goes up. So let's look at this example. If we invest $3,000 on an investment account paying 3% interest compounded quarterly, how much would the account be worth in 10 years? So this is the same formula we've been dealing with. So P naught is $3,000. Our interest rate is 3%, which would be 0.03. And compounded quarterly. So our little chart from before says n equals 4. And we want to know what would it be in 10 years. So the amount in 10 years would be P naught times 1 plus 0.03 divided by 4, the 4 times 10 years. So that would be 3,000. I know that 4 times 10 gives me 40. Let's calculate what's in the middle here. And so I would take on my calculator here, let's see, I'll put it here. I have 0.03 divided by 4, and then I'm going to add 1, and then I'm going to raise it to the 40th power. Then I'm going to take it times 300, or 3,000. And that gives me, I'm going to round up here, so that gives me after 10 years is $4,045.05. Oh, I guess I could have put that number in here. What was that? It was 1.0075. Alright, another example. 529 plan is a college savings plan that allows relatives to invest money to pay for a child's future college tuition. The account grows tax-free. Lily wants to set up a 529 account for her new granddaughter and wants the account to grow to $40,000 over 18 years. She believes the account will earn 6% compounded semi-annually, which is twice a year. To the nearest dollar, how much will Lily need to invest in the account now? So let's identify our parts that go into our formula. So I know that right now I have my rate is 6%. So it's 0.06%. It's compounded semi-annually, so n equals 2. She wants my amount in 18 years to grow to $40,000. So she says over 18 years, so t equals 18 years, and we need to know how much she should invest. So let's plug what we know into the equation. So $40,000 is equal to the initial amount, which we don't know yet, times 1 plus the rate, 0.06, divided by the compounding periods, which is 2, times 2 times 18. And that gives me 40,000 is equal to P sub 0 over 1.03 to the 36%. Divide both sides by 1.03 to the 36 power. You can tell I'm getting tired. This is my last lecture of the day. So when I put this in my calculator, this gives me $13,801 that she needs to put into her account in order to get $40,000 over 18 years. If you have a struggle with your calculator, if you struggle with putting things in your calculator, you can always set up a time to meet with me in Teams so we can go over. I'll be honest, I don't know the Casio calculators very well. I do know the TI calculators very well. Between you and me and the internet, though, we can figure something out. So please let me know. Don't let that be a barrier.